Class, welcome to our next video. We are jumping a little bit ahead to actually, in the book, this would be chapter 11. But we're throwing it in here. It kind of has to do with rational functions. We're going to be looking at rational functions. We're going to be breaking rational functions apart. And that is why we call this decomposition, because we are going to decompose fractions. So, before we get started, I want to actually compose some fractions or add fractions together to kind of show you what that, or remind you what that looks like. So if we have something like negative 2 over x minus 2 plus 3 over x minus 3, hopefully we remember to do this and to add fractions you need to have a common denominator. So you'd have to do some work like that. What do we know here? Well, this would equal, we would only need one fraction bar. We'd have x minus 3 and x minus 2 on the bottom. And then we'd have to distribute, so like negative 2x plus 6. Right? That's that distribution. This distribution would be positive 3x minus 6. So our final answer here, sorry, that's a 6. Our final answer here would be x over x minus 3, x minus 2. So what I really want you guys to understand here and see is that our final fraction, all right, our rational function here, x minus 3 times x minus 2 in the denominator, that came right from our two original pieces. All right, and so really what this partial fraction decomposition is going to do is we're going to give you something like this and work to get here. All right, so there are some steps for that, and we'll get there in a little bit. Before we do that, just remember our standard forms. I'm going to start down here with a constant, and I'm just going to say a constant we would call just a. All right, I know this is a constant. Technically, this is actually a x to the 0th power, right? Its degree is 0, so we just write it like this, a. Now, if we have a linear factor, well, we would have to say ax plus b. All right, ax plus b. Why? Because now if it's linear, x has a degree of 1. And we can keep going. Quadratic, we know, would be ax squared plus bx plus c. We could go even further. We could say that cubic is ax cubed plus bx squared plus cx plus d. And honestly, you guys could just keep going and going and going. But this is important, and one thing, or one reason why it's important is because we need to understand this concept of degrees when we move on to this next step. So the first one, I kind of want you to just watch / write down with me, and then we'll go through some steps, and then we'll try some more together. So the very first thing I need to do here is I need to say, well, x minus 5 over x squared minus 5x plus 6. I can simplify this a little more, or I can factor. So I know that this is going to be x minus 5 over, let's see here, what? X minus 3, x minus 2. All right. So here's the deal. Now that I have it simplified, or at least in factored form, I can write x minus 5, x minus 3, x minus 2, all right? And this is going to equal something. What I need you guys to think about here, these were my original denominators. This was the denominator when I combined them, when I composed them. What would happen if I decompose this? Well, it would have to go back to the originals. So what I want you guys to do now, and what you'll always do, is split the denominator into separate pieces. All right? So over here, I'm going to have an x minus 3. Over here, I'm going to have an x minus 2. All right? After this step, what I need you to understand is the numerator should always be 1 degree less than the denominator. So because the denominators are linear, that means my numerators have to be constants. And so here I'm going to use A and B. Just be careful, we can't use the same letter. They're not going to necessarily be the same. You have to solve for them differently. So we change the letters. After this, what we're going to do is we're going to try to start to clean this up a little bit. And to do that, I'm going to multiply the entire equation by the greatest, or the common denominator, I should say. All right. Why do I do that? Because when I distribute these two pieces here, well, what's going to happen? They're just going to cancel. They're both going to cancel, and I'm going to be left with x minus 5. What happens when I multiply these two over here? Let's do it over x minus 3, x minus 2. Well, what happens? It looks like the x minus 3's are going to cancel, which means I will have a and then x minus 2. And lastly, when I multiply over here by x minus 3, x minus 2, what happens? The x minus 2's cancel, x minus 2's, yeah, I guess that works, cancel, and I'm left with b times x minus 3. All right. We are almost there. We're getting really close. The last thing that we're going to do to kind of figure out what those a and b values are, because that's what we need in order to fully decompose this fraction. We are going to find, and almost like the zero product property, or similar to it, we're going to find how to make our factors zeros, if possible. All right, so I'm going to move up a little bit, and I'm going to say if I set x equal to 2, it's going to completely get rid of this piece right here, and it's going to make it really nice and easy to find b. All right, so I'm going to set x equal to 2, and I'm going to plug in 2 minus 5 equals a, 2 minus 2 plus b, 2 minus 3. Okay, now you don't have to do all of this every time. I'm just trying to show all my work the first one. So negative 3 equals a times 0 is nothing. So really, we just have 2 minus 3, so negative b. And then we can go ahead and we can say that b has to equal 3, which is great. All right. Now, there are other ways to get the a value, but I would say in this case, go ahead and do the exact same thing, but let's get rid of this piece right here now. What do I need to set x equal to get rid of this term right here? Let's change colors. X should equal 3. All right, if x equals 3, well then I'm going to have 3 minus 5 equals, sorry, that's a 5. A times 3 minus 2 plus b 3 minus 3. And as I do this, let's see here, I get negative 2 equals 3 minus 2 is 1, so just a, and then we said this was going away, right? So we don't even have to do any other work. We're done with that piece. So now that we have our a and our b values, we're ready to write out the completely decomposed fraction. And I'm going to rewrite the original, so x minus 5 over x minus 3, x minus 2, and this is going to equal, well, a over x minus 3, or negative 2 over x minus 3 plus b over x minus 2, or 3 over x minus 2. And we have now successfully gone from a composed fraction to a decomposed fraction. All right, so again, we are going to outline these steps, and then we are going to try a few more that are a little bit different, and then we'll have you guys practice. Okay, so the first thing you have to do, gotta factor. Have to factor. I guess I can even say, no, I'll just leave factor. No. Factor the denominator. That's what I need. I need the denominator factored. Once you have that the denominator factored, you're going to be able to split the factors of the denominator into separate fractions. Okay, and just to highlight this, this is what I did right here. I had my two factors and I split my fractions. Alright? I split the factors into their own separate fractions. The next thing you have to do is you need to set the numerators. Alright? So let's say place expressions for numerators. Excuse me. Place expressions for numerators, and remember, one degree less. Okay, 1 degree less. What do I mean by that? That means that if my factor in the bottom is linear, then my numerator has to be a constant. Alright, if my factor in the denominator was quadratic, well then my factor in the numerator would have to be linear. Alright, and we'll see that in a little bit. The last thing we do, or not the last thing I guess, the next thing we do, we multiply by common denominator so that denominators, oh, you can't see a word I'm saying, so that denominators completely cancel. And then lastly, plug in x values in order to find values of the numerator. Sorry. Okay. Alright, so these are good steps. This is something I would probably study, remember. I don't think it's super challenging, but again, it's going to take time and it's going to take practice. Alright, so now that we have this completed, first page, we're going to swing on over to the next page, and we're going to learn about a different type, or go over a different type, where we have repeated linear factors. Alright, what I want to do a quick little, I guess, warm-up again. I'm going to do it, actually, you know what? I'm going to do it down towards the bottom of this page. Alright, and I'm going to say if I have like 1 over x plus 1 over x minus 1 plus 1 over x minus 1 squared. Alright, now we're not going to actually do this problem, but what I want you guys to understand here is what would I have to do in order to get a common denominator, to actually add these? Well, I'd need to multiply this x, or this first piece, by what? X minus 1 squared. And I'd need to multiply this one by an x from this right here, but also another x minus 1, right? Because this x minus 1 is squared, and that's what we're going to need to get a common denominator. And then lastly, this piece would just be an x and an x. And what I'm really trying to get at, and the only thing I really care about right now, guys, that you understand, is that this is my common denominator. Alright? When I give you a composed fraction that has a repeated linear factor, like there's multiplicity, then you need to actually, and I know it's kind of goofy, but you need to take into consideration that there can be that actual x minus 1 and it's squared, but you could also have just a linear factor by itself in the decomposed part, okay? So this is going to be a little bit more challenging, but again, it shouldn't be too bad as long as you start the problem correctly. And by that I mean, when we have repeated linear factors, you must write separate fractions for each degree of that repeated, oh, I'm off the page a little, of that repeated factor. All right, we're going to see what I mean in a little bit. Okay, so similar start. I'm going to factor this. What do I got? I got x plus 2. I know I can take out an x right off the bat. So that would leave me with x squared minus 2x plus 1. Ooh, I know this one, right? This is going to be x plus 2 over x and then x minus 1 squared. Oh, interesting. Looks kind of familiar. Okay, this is what I'm getting at. I know that I have a repeated linear factor here. So the easiest one, and again, this x is its own linear factor, so I can absolutely just write a over x. All right, that's the easy one. This is the tricky part. B, I need to include x minus 1 as a separate. Yeah, because I can have an x minus 1, again, if I go back to my original, this x minus 1, you see how I had this x minus 1 and it wasn't squared in my decomposed fraction? Well, I need to take that into consideration when I am decomposing. All right? And then lastly, I have x minus 1 squared. This is still linear, right? This is a linear factor, so I just need a c. All right. So again, and let's see, you must write separate fractions for each degree. I don't really like how I wrote this. I'm going to try to come up with something better for you guys, but I hope you understand what I'm trying to say, is that when you have multiplicity or a higher degree, something repeated, you need to include all of the different possibilities. All right. Now after this, it kind of turns into the same thing. I am going to have to multiply every single thing by x minus 1 squared. Well, what's great? This completely cancels. I just have x plus 2. When I multiply this piece right here by a over x, the only thing that's going to cancel is the x's. So I'm going to have a and then x minus 1, x minus 1. You could write it as x minus 1 squared, not the end of the world. It might just be easier to see it. Let's see here. Next one. B, when I multiply, what's going to cancel? One of the x minus 1s is going to cancel. So I'm going to have x and then one more x minus 1. And then lastly, when I multiply x minus 1 squared, by c over x minus 1 squared, the x minus 1 squareds should cancel. So this would just be cx. Alright? Alright. Now, the first thing, the one that's kind of staring at me in the face, is if I set x equal to 0, that's going to get rid of both of these pieces. Why? Because anything times 0 here is going to be 0, and then b times 0 times anything will also be 0. So that is why I do this one first. I'm just going to go right to it now, guys, okay? You know how to plug stuff in. So 2 equals negative 1 times negative 1 is positive 1, so 2 equals a. Done. I now know my a value. Let's take a look here. I think another nice value, if I could get rid of a's, or this a, the term that has a in it, by plugging in 1. So let's try that. If I set x equal to 1, well, 1 plus 2 is 3. This is going to go away. This is also going to go away, right? Because this 1 minus 1 here is a 0. So both of these pieces are going to go away, and I'm just going to have 3 equals c. All right. Now, for the last one, there's no other factors that I can get to 0, so I really just pick something that's going to be nice. Personally, I would say if I plug in a 2, it'd make it pretty nice because 2 minus 1 is just 1. Alright, so it's going to make the calculations kind of easy. So if I set x equal to 2, let's see what happens. 2 plus 2 is 4. And what did we say? 2 minus 1 is 1, so 1 times 1. So this is just a. If I plug in 2 here, I get a 1. Times 2 is 2, so 2b. And again, I plugged in 2, so this is plus 2c. Now, we know some things, don't we? We know 4 equals, what do we have? 2 plus 2b plus 2 times 3 is 6. Alright, so we're getting there. We're getting there. Let's clean this up now. 4 equals 8 plus 2b. Negative 4 equals 2b. b equals negative 2. Alright, and now we can write our final answer. We can say x plus 2 over x minus 1 squared will equal, well, let's go back. A over x, my a value was 2, so 2 over x plus b over x minus 1. b was negative 2. Oh, sorry guys, my bad. X plus 2 over x times x minus 1 squared equals a over x, or 2 over x. Now my b value is negative 2, so b divided by x minus 1 means I would write negative 2 over x minus 1. And then lastly, my c value was 3, so 3 over x minus 1 squared. And that should be my final answer. Now again, this is what I was talking about earlier. I want you to understand that when you have this denominator with a repeated factor, a repeated linear factor for that matter, it's going to end up with 3 pieces. All right, you need to have a piece for the repeated piece, and if it was just kind of solo. All right. I know it's getting long. We have one more that we have to do. Hopefully it won't take too long, and I think we'll understand how this one's going to work when we get there. All right. Okay. Last one. Ooh, what do we have in the bottom here? We have difference of cubes. So 3x squared minus 2x plus 2. I need to factor the denominator, so we use our SOAP method. I know it's going to be x minus 1. So it's same, and then it's opposite. 1 times x is x, and then it's always positive for b squared, or in this case 1 squared is 1. Alright, now this is different looking than what we've seen before. We've never had a quadratic. But we can do this with quadratics. It's going to be very similar. We're just going to have to remember the numerator has to be 1 degree less. So let's take a look. 3x squared minus 2x plus 2 all over. This is me just repeating, or rewriting, sorry. I have 2 pieces, right? So that means I want to split my fraction. I want to split this up. I'm going to have an x minus 1 in my first piece. This is linear, so I just need a constant in the numerator. Now, the part that changes. I now have a what in the denominator. This is a quadratic, which means I need a linear in the numerator. Okay, again, linear means constant in the numerator. Quadratic means linear in the numerator. Alright, and now it really turns into the same exact thing, guys. Alright, I'm going to multiply absolutely everything by my denominator. because I need denominators to cancel. And when I do that, I should just be left with this numerator because this completely cancels each other out. Let's see what happens. When I multiply this denominator by this piece, what cancels? The x minus 1s. So I'm going to have a times x squared plus x plus 1. And what's going on in this next one? When I multiply this denominator, right, by everything here, what cancels? Well, the x squared plus x plus 1. So I have plus bx plus c x minus 1. Perfect. All right. So let's take a look here. I think the easiest thing, the one that's kind of sticking out in my mind right now, is I can change this to a 0, which means I can completely get rid of this, and I can probably get my a value. So what do I plug in for x to make this equal to 0? I plug in 1. So if I set x equal to 1, and I start solving, well, we have to do a little bit of calculating. So 1 squared, 1 times 3 minus 2 is 1 plus 2. Okay, so 3 equals, let's see here, plug in 1. 1 squared, 1 plus 1 plus 1. So 3a. And then again, if we plug in 1 here, hopefully we remember this is going to completely get rid of this piece. So I know that a has to equal 1. All right. The next one that's kind of sticking out to me that I think can help me out, and it's a little tricky, we kind of have to start playing around and using some of our algebra skills, but I can at least get rid of the b value by plugging in a 0 for x. And that way I can at least get something down to a and c, and then don't we already have a? We sure do. Alright, so what I mean by that is if I plug in a 0 for this x right here, well, all the x's, but if for sure right here, it completely gets rid of this b piece, and that's what I'm going to do. So I'm going to set x equal to 0, which means I have 2 equals a, right, because 0 plus 0 plus 1 is 1, so 1a, plus, now be really careful, this piece goes away, the c stays though, right? The c has to stay. So that means I'll just have c times negative 1. So let's write it like that, c times negative 1. Alright, so if I keep going here and I plug in, well, I knew a was 1, so 1, and this is going to be minus c. So now when I move this over, I get that 1 equals negative c, or c equals negative 1. Sorry, a little bit off the page there. Alright. At this point in time, guys, there's nothing else that I can get rid of, right? We couldn't reduce this, we couldn't factor this, there's no way to get this to 0. I've already exhausted my options for getting rid of, so really you just need to pick something that you think will be helpful in trying to get rid of. And what I mean by that is I would probably say I would plug in a 2 again. Make a factor nice. Like changing something to a 1 is probably your nicest bet. So if I change, let's change to red here. I'm going to plug in 2. So let's see here, 2 squared, so this will be 12 minus 4 plus 2. That's going to equal a times, what do we have? 4 plus 2 is 6, so 7. Plus, what do we have here if we plug in a 2? So 2b plus c. And then that would just be multiplied by 1, right? 2 minus 1 is 1, so we just have 2b plus c. So now plug in what we know, and we can start to solve a little bit. So this would be 8, 10, 10. 10 equals, what did we say? A was 1, so this will just be 7. 2b, we don't know yet. C we knew was negative 1. Alright, so as we start to clean this up, and this is just algebra here, we have 6 plus 2b, or we have 4 equals 2b, or we have b equals 2. Alright, so we can finish this up by saying our final, so 3x squared minus 2x plus 2 all over x minus 1, x squared plus x plus 1 equals, and now we just plug in our values. We knew that a was 1, so 1 over x minus 1, and we knew our b value was 2, so plus 2x, our c value was negative 1, so 2x minus 1, all over x squared plus x plus 1. Okay, so this video was pretty long. I apologize for that, but partial fraction decomposition is definitely something that is a little trickier, and I think it's important for you to understand the steps and go through all of these different types of problems. Alright, so I hope you guys understand these concepts. I hope you are making sense of it, and we will practice more tomorrow. Have a good day.